Solving quadratic equations with complex solutions. Now that we have learned about complex numbers and different methods to solve quadratic equations, let's consider solving a quadratic equation with complex solutions. If we are given the quadratic equation ax squared plus bx plus c equals 0, and a is not equal to 0, where a, b, and c are real coefficients, the complex solutions are going to be found using the quadratic formula. If the discriminant b squared minus 4ac is greater than or equal to 0, then the solutions are going to be real numbers, because we're going to be able to take the square root of this positive number when it is greater than or equal to 0. But if the discriminant is less than 0, meaning it is a negative value, then we're going to have complex numbers as our solutions here. And the quadratic formula gives us these complex solutions. We have the real part, which corresponds with the axis of symmetry, but then we have a plus or minus the square root of 4ac minus b squared times I over 2a as the imaginary part. Now some of you may be like, wait a second, how did I get from b squared minus 4ac to 4ac minus b squared with an I after it? Well, let's actually take the quadratic formula and first split it. So we have negative b over 2a plus or minus. We'll have the square root. Let's first reorganize what is inside of the square root and put negative 4ac in front and then plus b squared. And then this is over 2a. Now if I factor a negative 1 out of there, it'll become negative b over 2a still, and then plus or minus square root of, we have negative 1, and now we have 4ac minus b squared inside of the parentheses here over 2a. Now this negative 1, that's where this I comes from. So when we take the square root of negative 1, that's the I component, and the remaining discriminant is 4ac minus b squared. Let's try solving some quadratic equations that have complex solutions. Here's an example. We have to solve 5x squared minus 2x plus 3 is equal to 0. First, let's identify our a, b, and c values for the quadratic formula. Our a value is going to be 5, b is going to be negative 2, and c is going to be positive 3. So then if we substitute these values in for the discriminant, we'll have negative 2 quantity squared minus 4 times 5 times 3. And then when we evaluate this, negative 2 squared is positive 4 minus 60. That's going to give us negative 56 as our discriminant value. So now let's finish figuring out our x values if we know the discriminant is negative. So we're going to have negative of, our b is negative 2, plus or minus square root of negative 56, because again we found the discriminant early, all over 2 times 5. So then we're going to have positive 2 plus or minus, there's an I that we can bring out, and also 56 in and of itself can be factored. And the perfect square that divides into 56 nicely is 4, and it goes in 14 times. So we're going to have a 2 that can also come out because the square root of 4 is 2, and we're left with 14 inside of the radical, and then all over 10. And then since all of these coefficients have an even value, we can simplify to have it be 1 plus or minus I square root of 14 all over 5. If you rewrite them as individual fractions, you would have then 1/5 plus or minus I times the square root of 14 over 5. So either of these answers are acceptable. And here we can see the solutions, and they do match the solutions that we found. They, instead of simplifying and writing 1/5 plus or minus I times the square root of 14 over 5, they converted the 1/5 each time into decimals. So it's also equivalent to 2/10 plus or minus 2/10 times the square root of 14 times I. Here's another example. We're going to solve the quadratic equation x is equal to 2x squared plus 7. The first thing that we have to do is move some of the terms around because this is not equal to 0 yet. The easiest way to do that would be to subtract x from both sides. So then we'll be left with 0 on one side of the equation and then 2x squared minus x plus 7 on the other side. Now we can identify our a, b, and c values. A is 2, b is -1, and c is 7. And then we can substitute these values into our formula for the discriminant, which is b squared minus 4ac. So we'll have -1 squared minus 4 times 2 times 7. So we'll have 1 minus 56, which is -55 for the discriminant. So now let's finish solving our quadratic with the quadratic formula. So our -b value is negative of -1 plus or minus the square root of -55, because we worked it out already, all over 2 times 2. So we have +1 plus or minus this -55 is equivalent to -1 times +55, and the square root of -1 is I, and the square root of 55 cannot be broken down further, and then all over 4. You could leave your answer in this form. You could also elect to split it up into two terms, 1/4 plus or minus I times the square root of 55 over 4, and you could also rewrite these as decimal values. So you could have 25/100 plus or minus 25/100 I times the square root of 55. Any of these last three answers would be acceptable. And here we see the solutions to our quadratic, and they do end up equaling the same values that we found. We have 1/4 plus or minus the square root of 55 over 4 times I, or you could write it as 25/100 plus or minus 25/100 times the square root of 55 times I. The discriminant, capital D, is equal to b squared minus 4ac, is the quantity that indicates the nature of the solutions of a quadratic equation, given that ax squared plus bx plus c is equal to 0, where a, b, and c are real coefficients, and the table below summarizes our possible outcomes or solutions. If the discriminant b squared minus 4ac is less than 0, then we are going to have two complex solutions. We're going to have an I in there. If the discriminant b squared minus 4ac is equal to 0, then there is one real solution, and that one real solution is actually the vertex of our parabola. If the discriminant is equal to b squared minus 4ac, and that is greater than 0, then there are two potential outcomes. If this discriminant gives us a perfect square, such as 9, 25, 36, 49, etc., then we are going to have two rational solutions, because you can square root 9, you can square root 25, you can square root 49. Like, those are going to give us rational solutions. If b squared minus 4ac is not a perfect square, say it gives you the square root of 10, it's not a perfect square, so you're going to have two irrational solutions.